today our lesson 2, graphic representation of moving in a straight line. First, physicists use mathematical relation like graphs and tables in order to predict relation between physical quantities, to understand practical results, and to describe physical phenomena in an easier way. Let's see a graphic representation of regular speed or uniform speed. Do you remember regular speed? It's the speed that the body covers equal distance and equal period of time. Here we will use this table to know the relation between distance and time in uniform graph. We will draw the graph, the distance in vertical y-axis and time in horizontal x-axis. And then in the 5 seconds, the body covered a distance 0.4. In 7.5 seconds, the body covers 0.6 meters. And in 10 seconds, it covers 0.8 meters. 12.5 seconds, it covers 1 meters. So the graph represented by a straight line passing through the origin point. Origin is the point of the intersection between the two axes, the y-axis and the x-axis. Okay? So the graph here, the uniform or regular speed graph of distance and time, represented by a straight line passing through the origin. Let's see the uniform graph with time and speed. We'll use the same table, but here we will identify the graph of time and distance graph for uniform speed. We will draw the graph speed on the vertical y-axis, time on the horizontal x-axis. Okay, 5 seconds, the speed of the body is 0.08. 7.5 seconds, the speed also 0.08. 10 seconds, 0.08. 12.5 seconds, 0.08. Why? Because it's a uniform speed. Remember? Uniform speed, the body covers equal distance and equal period of time. So V1 equal V2 equal V3 and so on. Here, the graph represented by straight line parallel to the time axis. Okay, so here in uniform speed graph, when the two axes, distance and time, the graph represented by straight line passing through the origin point. When the graph speed and time in uniform speed graph, the graph represented by straight line parallel to the time axis. Let's see the difference between them. This is uniform speed and this is uniform speed. While here distance and time, the speed and time. This graph represented by straight line passing through the origin point. Here, the graph represented by straight line parallel to the time axis. Concentrate, students. These graphs for uniform speed. Distance, time, straight line passing by the origin. Speed, time, straight line parallel to the time axis. These graphs for uniform speed. While when the body is at rest, distance and time graph for the body, it doesn't move. The graph represented by straight line parallel to the time axis. It looks like what? Yes, it looks like speed and time graph for uniform speed. While here you have to focus on speed, time. Here, distance, time. So you have to differentiate between this is body at rest, while speed and time graph, uniform speed. Both of them are represented by straight line passing by straight line parallel to the time axis. While distance and time, body at rest. Speed and time, uniform speed. So we have three graphs. regular speed and body at rest. Okay? Acceleration. Acceleration is the change of the object speed in 1 second in a specific direction. When the speed changes, means acceleration. When the speed changes, it means we have initial speed and final speed. Acceleration is symbolized by A. Change in speed, delta V. Delta, it means change word. In time, delta T. Change in speed, it means we have initial speed and final speed. So acceleration equal final speed V2 minus initial speed V1 over delta T. This is our rule for acceleration. Again, acceleration is the change of the object speed in 1 second in a specific direction. Its rule, A equal final speed minus initial speed over time. Measuring units of acceleration. Acceleration unit, it means speed unit over time, because what's meant by acceleration? Change in the object speed in 1 second. So we have speed and we have time. The measuring unit of speed, meter per second, and the measuring unit of time is second. Measuring unit of meter per second, meter over second, time 1 over second equal meter over second square. So the measuring unit of acceleration, meter per second square. Concentrate, students. The measuring unit of speed, meter per second. The measuring unit of acceleration, acceleration means change in the object speed in 1 second. So we have speed and we have time. Its measuring unit, meter per second square. Okay? Now we have to concentrate. The acceleration meter per second square when the speed is meter per second and the time is second. The acceleration unit, kilometer per hour square, when the speed is measured in kilometer per hour and the time is 1 hour or measured in hour. Okay? Now we have guidelines to solve the problem of acceleration. First, to calculate acceleration, we have a magic triangle. Acceleration equal delta V over delta T. If I want to calculate acceleration, delta V over delta T. Delta V, it means a change in speed. As we said, final speed minus initial speed. What if I want to get delta T? Yes, equals delta V over A. If I want to calculate delta V, A times delta T. A is for acceleration, okay? If the body is moving at regular speed, the acceleration equals 0. Give reason. Why? Because acceleration means change in the object speed. When the body moves with a regular speed, it means the speed doesn't change. So the acceleration is equal 0. If the body starts moving from rest, when the body moves from rest, it means the initial speed V1 equals 0. Focus on this point. When the body starts moving from rest, it means the initial speed V1, final speed V2. It means initial speed equals 0. When the body stops, when the body is moving, and then the body stops. So its final speed equals 0. And also when the car is moving, then the brake is applied to stop the car, the final speed equals 0. These guidelines are very important to solve any problem. Let's solve a problem. If a bus moves in a straight line, its speed changes from 8 meters per second to 20 meters per second. Concentrate, students. This measuring units is not for acceleration, it's for speed. And the body moves in a straight line when the speed equal 8 meters per second to 20 meters per second. From these words, what do you conclude? Yes, 8 meters per second is initial speed. while 20 meter per second is final speed. So 8 is V1 and 20 is V2. Within a period of 3 seconds, this is time. What is the amount of acceleration? It's very easy. V2, 20 meter per second, as we said. Why? Because the body moves from 8 to 20. So 8 is the initial speed and 20 is the final speed. V1, 8 and V2, 20. Delta T equal 3 seconds. Our measuring units here are meter per second, and seconds. If we have time in hours, we have to convert it into seconds. Okay, concentrate. So we have to write the rule. Acceleration A, V2 minus V1 over delta T, 20 minus 8 over 3 equals 4 meter per second square. It's a very important point. We have to get acceleration. The measuring unit of acceleration meter per second square, while meter per second is the measuring unit of speed. Another problem. It's a very tricky problem, so concentrate with me. An object moves at an initial speed, okay? That equals 7.5 meter per second. Calculate the amount of time. Okay, here we have to calculate the time, not the acceleration. The final speed of the object becomes 4 times as its initial speed. What? Its final speed 4 times its initial speed. Its initial speed is 7.5. Okay? So the V2 final speed equal 4 times 7.7, which is the initial speed equal 30 meter per second. And knowing the object moves at acceleration equal 10 meter per second square. 10 meter per second square is the acceleration. We have to get time. If I want to get time, equal delta V over A, as acceleration equal delta V over delta T. When I want to get the time, delta V over A from the magic triangle. Delta V, V2 minus V1. We get before V2 4 times 7.5, 30 meters. And V1 7.5. Over the time is 10 seconds. So the time 2.25 seconds because we calculated the time.